Yes, this is a group that has a long history. In ITK is more than 30 years, active with the network synchronization topics, initially looking at the needs for transport networks like SDH and OTN, but more and more important became the interest on how to distribute synchronization towards connected applications such as radio base stations. And with every new generation of radio networks, there are normally new requirements, new studies and documents to be developed by this group. It was particularly important, for instance, with the 5G, the wide use of time division duplex, so the need to synchronize in time radio base station. But there are new emerging needs. For instance, we have been recently working at the needs for synchronization in data centers, because especially in AI cloud data centers, it's important to control the power consumption and latency. And it has been seen that by synchronizing the servers, it is possible to achieve good improvements in this area. And on this respect, we just recently released a document that provides a comprehensive analysis on synchronization requirements and solutions to meet these requirements.
Well, it's become quite important. Sync has increasingly become fundamental to much of critical infrastructure. And critical infrastructure not only includes telecom, but also finance and the power industry, among many others. So this has led us to focus our attention on robust and resilient solutions. To give an example of one of these, the central clock for timing we call the primary reference time clock, PRTC. We have extended this PRTC in a couple of ways. First of all, there is the enhanced PRTC, which integrates GNSS with a standalone atomic clock. Secondly, the coherent network PRTC, which connects these ePRTC clocks together with high accuracy fiber connections. We are also cooperating with the IEEE. They have initiated a project P1952, which is focused on the resilience of, among other things, time. And we are working to map some of our work that I've just described into the P1952 resilience categories.
Yes, as mentioned by Lee, it will be important to continue to improve the resiliency in network synchronization. That's an important point. Then I mentioned before that we are addressing the needs of the connected applications and radio networks needs. And as moving towards 6G, we expect new and more stringent requirements. Functions such as integrated sensing and communication. That is a function that practically makes the radio network becoming as a radar that is able to track and characterize objects in the environment. And this can be used, for instance, to augment functions such as extended reality or digital twinning, but can also enable new functions such as recognition of activities in the environment. And to make this working, it's required to synchronize the radio base stations very accurately. And there are, in the future, we expect even more stringent requirements, for instance, coming from the quantum technologies, such as in quantum key distribution networks that requires sub-nanosecond type of accuracy. On this respect, we are also looking at new technologies that can allow to meet this level of requirements. For instance, we are looking at new atomic clocks based on optical technology. So in summary, I would say that I expect that this group will get much work and will be busy for many years to come.